Okay. Okay. This is a homework, Abigail, is it?
Yeah.
Okay.
Okay, that's it.
Okay. Tell me what's your problem.
Well, for question 4, like I can't find oh
Mm-hmm.
what is the chloride of X?
Good question. Good question. Something that you should understand. Do you have an idea that chloride means something involving Cl? Just checking first.
Yes.
Okay. Now let's pretend that X is Na, right? The melting point of X chloride, right, is NaCl, correct? So NaCl is the chloride of Na. That's just, I mean, such a very fancy, it's a very fancy phrasing, right? For this one, XCl, no? NaCl. That's a chloride. You call it sodium chloride, man. Correct or not?
Okay.
Let's pretend that Y is something else. Okay, give me a random element for Y.
Helium.
Okay, helium. But helium is not a good example because helium is a noble gas, and noble gas doesn't form bond with other guys, correct? Remember, they are self-sufficient.
Yeah.
So choose somebody else, which is not noble gas.
Hydrogen.
Okay, let's say H. Now, the chloride of Y. Let's pretend that Y is H. So what's the chloride of H? What would you call that? It's HCl.
Oh.
Can you hear me? I believe. Right.
Yes.
Okay. Yeah. So again, what's the chloride of Y? Pretending that it's a Y is H.
Cl.
HCl, you mean HCl, right? HCl.
Yeah.
Are you familiar with HCl?
What do you mean by that?
Hydrogen chloride, or you usually know this as hydrochloric acid? That's my question. Are you familiar with HCl? Most people tend to be familiar with HCl after some chemistry lah. If you're not, that means you just haven't used it much yet.
No.
Okay. So let me confirm that how many practical sessions have you had?
2.
None of them involves acids lah. Yeah, they shouldn't be lah. None of them.
Yeah, none.
All right. Then soon enough in acid, you will see the very popular acid called HCl. Now, NaCl, however, should be something at least familiar to you. Are you familiar with NaCl?
Yes.
All right. So there's a table salt. Now, let me ask you something further. Let's pretend that it is now Mg. Okay. Now, what is the chloride of Mg, you think? Then chloride of Mg simply pairing the Mg with the Cl. Simply put. And that can happen in the world of chemistry. What do you think the pairing will result with?
Magnesium chloride.
And we are not wrong, but can you write the chemical formula of magnesium chloride? Now, around this chapter is where they teach you it is not MgCl, but it's MgCl2. Around this chapter, can I confirm, have they taught you why this should be MgCl2, or this is like completely new to you?
I think they taught us
Okay.
already.
Yeah. Then let me find out further. This MgCl2, is this ionic bond, covalent bond, metallic bond, or none of those three? There are only three bonds, right? Or you don't know?
I don't know.
Now that would be troublesome because by right, this is clearly one of the bonds, and they don't have to tell you. You are supposed to know yourself. That's what you're learning in this chapter. No? Oh, this guy, yeah, I know whose bond is this, and that's very important. That is the importance of this chapter. From now on, if you see a substance, a compound in this case, you need to be able to know without them telling you this is ionic, metallic, or covalent bond. It affects everything from now on. It affects how you think about them from now on.
Okay.
Right? So take a stab, take a guess. One of the three bonds, ionic, covalent, or metallic. Which one is this?
Ionic.
And you would be correct. What do they teach you about ionic bond?
Metal and non-metal.
Do you know that Cl, part of the chloride, Cl is non-metal? If you do not know, please tell me.
I know.
All right. Okay, so far so good. You have some familiarity with chloride. How about magnesium? What do you think that is? Maybe you have never seen magnesium in real life.
Metal.
Metal. So metal and non-metal will automatically form ionic bond. If that's your thinking, so far so good, you're correct. I'm gonna go a bit deeper, okay? I'm gonna go a bit deeper. How about HCl? Is HCl an ionic bond?
No.
Then what bond will that be?
Covalent.
You are absolutely correct. So you know something and definitely something important. Now, let me ask you further. How about Mg? Only Mg, okay? Only Mg. What kind of bond do they have? You can also say they has no bond, if you think so.
No bond.
Wrong. It is metallic bond.
Oh. Okay, I don't think they taught us this yet.
So haven't reached metallic, but definitely talk about covalent and ionic. You're saying?
Yes.
Okay,
Yeah.
good to know. That's always the weird part of the syllabus, but I noticed that they teach that way. Ask you again. Cl2. This is not MgCl2. This is Cl2. What do you think? What bond? No bond? Some bond?
Covalent.
You're absolutely correct. So you do know something. And something. Now, let's talk about these questions, right? Let's talk about these questions. When you learn ionic bond, they teach you all sorts of stuff, right? Sometimes it's overwhelming. Now, they tell you something about melting point and boiling point. Now, the ionic guys have a very strong tendency to have what kind of melting point?
High melting point.
So usually high. And you are supposed to explain why it is high from this chapter. This question is for the explanation. So just remember that it's usually high. I'll tell you first, metallic also usually high. That's not weird from your experience. From your experience, metal don't melt like candles. Metal melt quite difficult lah. Make sense or not? Right? That's
Yes.
your experience. So nothing wrong with your experience. Your experience say metal is strong. You are correct. Hey, ionic also strong. You have never seen salt melt. You have only seen salt dissolve. That's not melting lah. So good. Ionic is usually high. Metallic is usually high. And covalent is usually
Low.
low. And again, the chapter will demand you to explain why, but never mind for now. Now, back to this question. No? The chloride of Y is solid. Of course, you're right. That's wrong. The chloride of X conduct electricity in the solid state. Of course, you're wrong. But do you know why? Because this is very likely ionic. Let me trace it back to you. Again, chloride is Cl. So this is your non-metal. Correct?
Yes.
Pair with chloride. This is non-metal. The melting point of X is very high. Oh, ionic lah. Oh, must be metal low. Conclusion. Do you understand?
Yes.
Why Cl? You don't know what's why. Confusing. But no problem. This is low melting point. Covalent lah. Then must be non-metal with non-metal. Must be lah. Correct? So C is wrong because ionic does not conduct electricity in the solid state. Another piece of information. Does it overwhelm you? Are you okay with this?
Yes.
Okay, good. So C is wrong. Correct. B is wrong. Correct. Now you have a conclusion about A. Correct or not? You have a conclusion about A. Right or wrong? A.
Wrong.
You're right. Wrong. You know what, Abigail? I like something about how you process things. This is statement is correct. And then you cross this to indicate that's incorrect. And I agree with you. You should be looking for 3 crosses and 1 tick with this kind of question. Make sense?
Yes.
Is question D a tick?
Yes.
Do you know why now?
Yeah.
What I like about how you do things is you don't do like how other people do. Other people will force it like this. This is correct, 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 and this is wrong. Kind of, they have to flip in their mind. Oh, A is wrong, so therefore it's a tick. It's very confusing. Very confusing, right? I don't know why people do that. I agree with you. Just cross 3 and tick 1. Okay, and you find the correct answer. Okay, please maintain that. Any questions for 4?
No.
We're summarizing the chapter. You don't know what's metallic, but you already know one thing. Metallic is also usually high. Okay, let's move on to the question 7, is it?
Yes.
Now, question 7 is already clearly talking about metallic bond because metals have metallic bond. You don't know what the heck that means, but that makes sense. Metals have metallic bond. What else can it be? Okay, this is already metallic bond, by the way. Layers of atom in metal can slide over each other. Is this new to you?
What?
Layers of atom in metals can slide over each other. Is that new to you?
Yes.
Okay. Going a bit ahead of the syllabus, so I don't know why your teacher have this as a homework, but a good student studies before the class, right? So that's what I'm gonna do. I'm gonna search something. You can see my screen sharing. No, I don't. No, cannot see that. Here we are. Metal formula. Maybe this one. No, cannot. Okay, too complicated, right? I'm looking for something simple. Okay, maybe this one. Okay, there you go. Apologies for the advertisement. Skip. Okay, that is a metal, okay? That's not a mirror, that's a metal. Don't know what metal, maybe iron, maybe don't know. Now what happened to the metal? What do you think will happen to the metal?
I don't know.
Take a guess. The metal is flat, and then some piece of equipment is pressing on the metal. So make a guess. What will happen to the metal? Will it break? Will it crumble? Will it disappear? What will happen?
It would bend.
It will bend. Let's see what happened, yeah? I think you're correct. Let's wait for a while.
Okay.
What is that? Oh, there you go. Did you look at that? That was the flat piece of metal. It becomes a, I don't know, that's a pot or something. I don't know. Right? This is how most metal will react when they kind of are pressed together, and then it becomes this pot. Am I making any sense right now? Does it feel like metal can do this? Like,
Yeah.
right? Glass cannot do that. Plastics cannot do that. Plastic and glass both will break. Metal surprisingly does not. Now imagine for a while how much this metal is, so to speak, being stretched without breaking. Metals must stretch from a thin piece just now to become a tin pot without breaking. That is layers of atom in metal sliding over each other without breaking. Am I making any sense?
Yes.
Which of the following property is not explained by this fact? Never mind. I'll talk about the property of what you saw just now. This is the metal deforming, right, into a shape that you want. Very nice, very nice. They make pots like this one. Every pot that you contain is most likely made by this if it is made of metal. These are called malleable. Malleable means you simply can form it. You simply can deform it by hitting it or pressing it. They are malleable. The word malleable connotes something flexible, so to speak. So metals are malleable. Why? Because layers of atom in metal can slide over each other easily without breaking. So that's malleable. Make sense so far?
Yes.
Let me confirm that this is new.
Yeah.
Okay, so layers of metal can slide, that's correct. And it leads to the fact that they are malleable. So this is definitely correct, look. Make sense?
Yes.
Now, you know that metals can conduct electricity, but that's not explained by sliding over each other. Definitely not. So, wrong, right? So, conducting of electricity is not explained by this. You already know the answer. The answer is D lah.
Okay.
Okay, never mind A and C first. Just never mind A. Okay. I have to show you A though. I have to show you A.
Are you showing me something?
I am. Are you seeing my screen? Just checking. You're seeing my screen.
Yeah.
Okay, and oh, there you go. There you go. So the video, right? Okay, again, pardon the advertisement. Okay. Okay, I want you to observe the fact that there's a copper tube there. There's a color of copper. Is this the first time you see copper?
No.
All right. Then do you notice that on the left of the machine is green, there's a copper tubing, something like that, which is like bigger. And on the right, there's a copper tubing, which seems smaller. Can you see that? Do you see that?
Yes.
Now, let's see what actually this all means. I'm trying to explain ductility, you see. Let's see. What is the machine doing? The machine is obviously pulling the copper, right? Do you notice that as the copper exits, the copper becomes smaller in diameter? Did you notice that? Did you notice that? Look at that.
No.
Okay, one more time, huh? I'm changing my pen. This. Oh, sorry. Okay, look at this. Look at this.
Yeah, I can't see the video.
You can't see the video.
Yeah.
Wait a minute. Just now I show you another video. Can you see it?
No.
Oh, why didn't you say that, Abigail? Oh my goodness. Right. Okay. Now I'm gonna
I
show
see.
you.
Okay.
All right. Okay. You mean when I talk about pots and pans, you don't see any video at all?
No, but I understand what you're saying.
Okay. Right. Okay. Now do you see some video?
Oh,
There
I
you.
see. Yeah.
Yeah. Okay. Grid machine, copper tubing, blah blah blah. Can you see that?
Yes.
Run the video. Notice what is happening to the copper pipe. Do you see that? The copper pipe is reducing in diameter. Do you see that?
Yes.
And the copper pipe seems to be lengthening. Do you see that?
Yes.
So shorter in the smaller in diameter but lengthening. You are basically pulling the copper into something smaller, right? This is what they meant by being ductile. It's also about pulling, but this is pulling into something longer and smaller. Why is this important? Because that's how we make small wires, I suppose. That's just how we do it. Metals are ductile. Most metals, you can do this to them without breaking. Something like that. Very useful for making useful metals, I suppose. Right? I'll just continue until it finish. It's very short. He continues to pull. I don't know how long he wants, but something like that. Now that is an example of the ductility of metal. Any metal can do that. Clear?
Yes.
Now, is this also layers of atom in metal sliding over each other?
Yes.
Yes, correct. So this explains that. Okay. The last one is alloy. I'll talk about alloy until you have talked about it. You haven't talked about alloy, right?
Heaven.
All right, so we'll ignore that for now, but just know that the answer is also correct, even though you do not know why. Right. Next question, please.
Oh, that's it.
All right. Okay. Can I ask you something? Does your chemistry teacher usually give you another homework? Like this is like the basic homework, and then after she discuss more on the topic, then she'll give you another homework, but that one is maybe the harder one or the more challenging one. Does she do that?
Yes, but
Okay.
I don't have that worksheet yet.
Right. I'll just wait for it. Why am I saying this? Because I notice when teacher give good worksheet, I notice that your worksheet are good and in a good timing. The timing is good. The challenge is suitable for what you're learning. Some classes do not have that privilege, and as a result, the learning becomes very difficult. Right? So I'm happy with the way the class is managed. Right? It'll be very helpful. Okay, good. No question on chemistry. Can we move on to A math then?
Yeah.
Changing Jamboard. So in A math though, I noticed that you almost never ask homework questions, correct?
Yes.
And does it mean that your A math teacher does not give you proper homework?
She gives us homework from the textbook, like the exercises.
Which is very good. I like that. I know that the textbook is useful, right? Science textbook can be a bit useless, but math textbook are useful if you want to score high lah, if that's what you want. How come you never asked them? You don't have
Oh, I
to, but
see. like get help from my friends. And also like
Yes.
the timing that she gives us the homework and like the due date doesn't match up with our schedule. So
Correct. Because we only have one time tuition, and that's why we should have 2 days tuition, right? We should split it. Now I understand. So I understand the reasoning. Now, what do you think about the help you get from your friend?
Huh?
Does it work well to you?
sometimes.
Right. Let's be a good student. Why don't we do some exercises before the teacher asks you to do so? Why not? Can we do that? Okay.
Okay, sure.
So we're gonna do what a good student do. A good student kind of prepares for the class. She doesn't have to understand what is going to be discussed tomorrow, but she just take a look and kind of feel, okay, this is what I'm gonna talk about. I think I'm a bit confused here, and I'm gonna take notice tomorrow. We're gonna do a version of that, okay? I'm gonna ask you to put in some exponent question from your textbook on the pages that your teacher have not reached. So just slightly ahead of the class. Please do so. Put in the question in the Jamboard. I am in the AMAT Jamboard.
Oh, actually, what I mean is that my teacher just finished the expo.
And so she should be giving you homework, but she has not.
She didn't.
She did. So why don't we discuss the homework?
Okay.
Mhm.
Okay, I uploaded something.
Itu bantal. Ingat beli bantal gitu.
Yeah, sorry about that. Right. Okay, so this is 6. Wait, this is the homework?
Yes.
Yeah, I'm a bit surprised. Okay, let's talk about it. Now, can you do A or not? A is like this is more like an e-math question, lah, right? So they're starting off with the e-math kind of exponent, lah. That means using your e-math knowledge, you should be able to do A lah, so to speak. Can you do it, or shall I discuss it right now?
Discuss it.
Okay, so in e-math, so that means this is a strategy that you want to use in e-math also. most of the time, changing base to make it the same works very well. What do you mean by base? Here is an exponent. The exponent has a base and has a power, or sometimes they call it the index. Okay. Now, notice that in this situation, the base is not the same. The index is also not the same. Not the same base, not the same index, nothing can be done. At least not with a calculator. The best, the workable strategy is to simply change the base. Everybody should have the same base. Do you follow so far?
Yes.
Now, if you want to change the base to make it all the same, you actually have to decide a base. And that decision is not explained by the question. You must make that decision. You must make a decision right now. What should my base be? Well, make a choice. Is the base 16, 32, 256, or something else? Abigail,
Yes.
did you hear me just now?
No.
Hello, did you hear me just now?
Yes.
Changing the base thingy, I was explaining it.
Yeah.
Okay, then do you have a decision? Make all the base into 16, 32, 256, or something else?
Something else.
Your choice. What could that something else be? The smaller, the better.
Four.
Let's try 4. Okay, everything should be changed into 4. That's what we are saying. So we should at least try that. Now, 16, 4 over 3, change to 4, power something. Now, this is doable using e-math knowledge. Can you do it or not? If you cannot, I'll show you how.
I don't remember how.
Okay, then you have a problem for your e-math and your a-math also. So let's tackle it. Now, you have made a decision based on, you don't know, but you did make a decision to change 16 to 4. Well, I'm going to focus on the 16 first. 16 is 4 square. So far, so good?
Yes.
So, of course, the 4 over 3 stays, correct? Make sense?
Yeah.
Now, all you have to do is, again, to use e-math to combine the powers, because your base is already 4. Great, you're sticking to your decision. So what is 4 power 2 power 4 over 3? Can you combine the power into one unified power? Can you do that? If you cannot, please tell me right now.
Yes.
Okay, then tell me what's the resulting power.
10 over 3.
10 over 3? 10 over 3, you say? 10 over 3?
Yeah.
Would you please test using your calculator? This is it equal to that? You can test using a calculator. Again, a skill that you need to do in exam. Are they the same?
No.
You're correct. They are wrong. They are not the same. Try again. Basically, I'm asking you to try what you think you can do until you find the correct answer. In the end, sometimes in this is like that one. You have another number to try.
8 over 3.
All right, please test that. And if it is correct, tell me. If it's wrong, tell me.
It's correct.
Good, totally agree with that. So your EMAT is not so bad. This is EMAT skill. EMAT doesn't mean easy. EMAT means it's basic, very important. So good. So far, so good. We have 4/8/3. Now, the second challenge, 32 cube root. Do you know that based on EMAT, this is 32 power 1/3? Yes or no? Do you know this or not?
Yes.
All right, so I've done that for you. Now you have to focus on changing 32 to 4 power, correct? Because that's the decision that you make. That's fine. Well, what is 32? 4 power what? You should use your calculator, by the way. There is no other way one. You should just test, hey, 4 power what is 32? Just test, 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 test. It's not 4 power 2, so maybe it's 4 power 3. I don't know. Test.
I get like a ugly number.
And what is that ugly number?
Like 2.378.
Which is very
something.
interesting, yeah? Which is very interesting that you can get that. How did you get that ugly number? I'm very curious.
Hold on.
Yeah, I'm very curious how come you have the ability to get that very exact ugly number. I hope you're not pressing 32 cube root lah. That's not what I mean lah. I don't mean 32 cube root, 32 cube root, you shouldn't press the calculator. You're changing 32 into 4 power something.
I don't know how.
Try 4 power 2. What's 4 power 2?
16.
All right, now try 4 power 3 lah, because 16 is not 32.
64.
All right, do you have a problem? 32 is
Yes.
clearly between 16 and 64, and it will be an ugly number. I mean, you can venture a little bit lah. Maybe you try a decimal. I mean, you can do that. Would you try? Maybe try some sort of decimal. Believe it or not, this is what you're supposed to do. You're supposed to try a number until you get it right.
2.5.
Oh, 2.5 works. How do you know? The calculator say, hey, I mean, it works, it works like that. It is true that 4 power 2.5 is 32. So you can use that to your advantage. Sorry, just a minute. Okay, 2.5. Now, using the EMAT knowledge, please unite power 2.5 and power 1/3 lah.
5/6.
All right, so let's put it there. 5/6. So currently we have 5/8/3 times 4/8/3 times 4 power 5/6. Looks very complicated, but it is actually on the right track. Are you confused so far?
No.
So the last one is a bit more of a challenge. This one is divided by 1/256 power minus 3/4. What a mouthful. You're supposed to, you can leave the division behind if you want to. You can also change it to times if you want to. That is up to you. Do you want to change it to times or do you want to leave it as division?
I'll change it to times.
Okay, if you change it to times, then something else must happen here lah. What must happen here? Do you know?
Flip it.
And go ahead and write down. Okay, I guess I agree with you changing it to times. I guess it's just easier, right? That's great. How about the power? You're missing the power there.
Yeah, I'm not sure about the power though.
You mean the power should flip or not? Is that your question? Should the power change or not? Is that your question? Should the power change or not if the inside flip?
Yeah.
Right? Something that can be answered readily by your calculator. Let me show you how. This kind of thing, if you face a problem or a doubt in exam, you got to settle your doubt. Very easy. 1 divided by that ugly number. Please check, is it the same as 1 times that? If your calculator shows you that the number is the same, then you must be correct. Make sense?
Okay.
Give it a try. Doesn't take long. Are they the same?
Hold on. Yes.
Now you are progressing. You like times better than division, right? And you know you are correct. In exam, this is progress. Now, what are you supposed to do? Back to the original strategy. What is the strategy? To make the base the
Same.
So can you please make the base the same? Now do what I have been doing. I've been helping you to do. Now you do. It's nice you found it. So now combine it with minus, combine it with the power, right? Okay, great. So now you have all base 4. Can't you do something about it? Like this one should now be, should now be nice to do. All right. You get some answer. Right. So, if this is exam, how do you know that you are correct, Abigail?
Type out the original equation.
Then confirm it using this, right? Okay, you are correct. I believe your answer key will prefer the base to be 2. But, the question never say what?
Yeah.
I believe you are correct. Because of that, I believe you're correct. If the question never say what the base is, then you can choose any base you want. This looks simple enough to me. I mean, to be fair, you can still equate this to 2 lah. So I guess that's another way of saying it. To be fair. Now, did you learn something? Anything new here?
The decimal part.
The decimal part. Now, what do you mean by that?
That the index can be the decimal, like the index.
Index can be decimal like the
Right.
index. Oh,
No,
2.5, the 2.5 thingy, the 2.5
Yeah.
thingy. Right, okay, okay. Understand? Yes, that's totally allowed. I mean, it can be a fraction, so why can't it be a decimal? Make that allowed.
Okay.
8.8 over 3 is that uglier than 2.5. So obviously 2.5 is allowed, but at least in A math. At least in A math. Regarding the strategy is equally important. Changing the base to be the same. Is that something new?
No.
All right, because I can tell you part C will require that also.
Okay.
Part C is even harder, but C will at least require changing of base. So why don't we copy and paste to the next page? You'll require a lot of things here. Now, when are you supposed to submit this homework?
Tomorrow.
Ah, okay, right. So go ahead in the next page. So you gotta make, oh, you did make a decision. Okay. Abigail, you make a mistake somehow. Find your mistake. There's one mistake. Otherwise, you're doing quite well, but you did make one mistake. Try not to tell you where. Ah, there you go. You're good. Okay, let's see how you will continue from here. Oh, this is so troublesome. Oh, this is so troublesome. Wow, I don't think you're supposed to learn all this. Let's see how you handle it.
Mm. Okay. I'm stuck.
What you Hey, come on, Abigail, you make another mistake. This one. Come on, Abigail. Your basic math cannot be like this one, yeah? Check out this one and this one. Be careful. That's a basic mistake. So far, so good. Now, the top one may confuse you, I agree, but the bottom one you should be able to do because it's times, right? And by the way, 1 over 7 doesn't count as 7. Make sense or not? 1 over 7, the base is 1 over 7. That's not 7. Don't think that 1 over 7 is 7. Just now, you hate 1 over 256. You want to change it to 256. In that sense, I don't know. I don't if that makes sense. 1 over 256 is not 256. 1 over 7 is not 7. If 1 over 7 makes you stuck, I suggest you go back to 7 power x and leave the division. That's probably easier to deal with. I hope that makes some sense. Okay, now if it's a division but 7 power x, can you do something on the bottom? Why is it plus x, Abigail? And why is that a cancellation? Abigail, don't do weird things. Do they cancel each other? Does this become 3 plus 2? Does it make sense, right? Correct? Is this right or wrong?
Wrong.
You're correct, so don't cancel it. Now, let me do a comparison. If this is times 7 power x, what will you do? You seem to be able to handle times better, so fair. So what will you do? Times 7 power x. So what will happen? Let's pretend that it's times first. And this will be absolutely correct. Now, doesn't your E-math teach you, if this is division, still E-math, then this simply becomes minus? Yes or no, you tell me.
I don't remember that.
I am extremely certain in E-math you need to do this. Extremely certain. So maybe you take my word for it. First, maybe you'll see it later that it is true. In exam, they will test this. Now, I'm going to compare it with what you did. You seem to be very uncomfortable with the division. It's not a good thing. That's what I'm saying. Because in E-math, you need to do that. In A-math, you also need to do that. Now, I'm going to do a comparison with this. You seem to be more comfortable with this initially because of the times. Again, you're not comfortable with the division. Okay, so far so good?
Yeah.
What is the problem with this though? The problem is this, that you don't understand a very important principle. The principle goes like this. My base is different. My power is different. There is nothing that we can do. Let me repeat this one more time. The base is not the same. 1 over 7 is not 7, no matter what. 1 over 2 is not 2. Half is not 2. No matter what, you cannot do something with this. The base is not the same and the power is all the same. One of them needs to be the same for anything to happen. That is the principle that I guess teacher don't say it that way. So I'll say it this way. If you are stuck here, there is nothing that you can do because of that. Am I clear?
Yeah.
Now, there is another way. There is another way. Some people will therefore do it because some people do not like the division so much. They decide to stick with times. They did do that. But they found a way to make it work. So they found a way to make it base 7. The power is minus x. It is true that this is equal to that. It is true that all these 3 is equal. It's just that if you have problem reaching this, then this is not available to you. Are you confused when I change this to that?
No.
If you're not confused, then maybe this suits you better because of the times. Then I will recommend you doing this lah. It's a good change anyway. E-math will also require to change it like that sometimes. Go ahead. If you like this, please do the third option. Right. Now, as you can tell, the third option gives you the same answer as the first option, the one with division. Okay. The second option will not give you anything because of the problem I mentioned just now. Okay. So go ahead, simplify it first. All right. Are we clear this so far so good?
Yeah.
Now, our problem remains. So we are already simplifying. It's very good. Now you look at this and you look at that. Okay, I'm going to continue. Now, let me explain the problem that now only exists in AMAT. So far, I've been telling you this is EMAT. This is EMAT. You need to know this for EMAT and AMAT. Okay. Now I'm telling you there is a very specific problem they will introduce only in AMAT. This is the problem. The fact that a plus or a minus is below. Below means at this level, not at this level. This is not a problem. Not a problem. You can handle that. This is a big problem, or rather a new problem in AMAT. Before I show you the solution, do you understand what I'm saying, Abigail? That the fact that this is a new problem in AMAT.
Yeah.
This will not exist in EMAT, I guarantee you. Because to handle this problem requires a different approach. You will never see that approach in EMAT. So you will never see that problem in EMAT. Okay?
Okay.
I will now introduce you a different approach. One more time. Why do I introduce that? My reasoning is very simple. I see minus below. That's it. I'm going to use that new approach. That is the only reasoning I have. Nothing fancy, no experience required. Understand?
Okay.
Now, the approach, therefore, new approach, new problem, new approach, right? The new approach is called let. So simple, let, or substitute. I believe your teacher should at least have talked about this, let or substitute. Yes or no?
Yes.
Now, for a let or substitute to work, you choose, same thing. When you want to change the base to be the same, you choose the base. You choose the base to be 7. I like your choice. Very good. Now, when you let or substitute, you're also going to choose who you are letting or substituting. The choice will involve a base and will involve a power. It is entirely within your choice. Understand? Entirely within your choice. So therefore, you have to choose wisely or with experience. Now, for your sake, I'm just going to choose for you first. I appear to randomly choose 7 and power 2x. This will now become y. So far, so good?
Yes.
I promise you, when you substitute, things becomes extremely simple. This I promise you. The effect of substitution is to make it look super easy, which is something that we like. Let's see whether it is true or not. Okay, let's see. Let's move on to the next page. Move to the next page and copy your latest result. Good. Now, I have asked you to make a commitment to substitute. So let's see what happens, right? Now, first thing first, notice that this one will become y lah. Okay, so far so good. This one contains y, so I'm going to do something about it. I'm going to extract y out of it. Okay, I'm going to deal with the -1. So am I correct? Abigail, are we okay?
Yeah.
Therefore, I get the y times 7 over -1. I would prefer to write this on 1 over 7y. That's just my preference. Do you understand?
Yes.
Do the same thing with 7 to x plus 1. You can get y out of it. Please do something similar. And that looks fine. You put a 1 just to declare. Yeah, declare to yourself. Great. And then you get the y. Immediately make it to y. Come on. Immediately make it to y. You made a commitment and then times 7. So 7y, right?
Yeah.
7y looks very not threatening. 1 over 7y is also not very threatening one. I mean, everything looks nicer when you substitute. Promise kept, correct? That was my promise.
Yes.
If you find that to be so, please continue using the substituted and then you will be able to simplify quite easily. In fact, it will feel like it's an easy math question. Give it a try.
Huh? I don't know how to continue from here though.
Why are you stuck?
Yeah.
Continue. I mean, use what you have substituted into the question, right? Now, Abigail, can you continue from here?
No.
Then I suggest you use 1 over 7y. I suggest. Can you continue from here?
Not really.
I refuse to accept that. Now, here's the reason. The promise of substitution is to convert something complicated into something that is very easy looking. In fact, this is now EMath level, EMath secondary 1. Believe it or not, you can do this. You should be able to do this. This is EMath secondary 1. Now, I won't do it for you. Instead, I will just help you try to see it. I'm not joking when I say this is at the level of secondary 1 EMath. Now, look at the numerator separately. what exactly is y minus 1 over 7y? Maybe you can simplify it, kind of, maybe. Nothing wrong with that. Now, what is 1 minus 1 over 7? Please, it's not a big deal. Change it into something even simpler. Right, and now write it in a more familiar form, 6 over 7y. And you would be correct. Over 7y. Now, again, can something be done out of this?
Yes.
And what would that be?
Kind of like remove the y.
I agree with you. The y can cancel each other here. Go ahead. So that's great. That's very good. Now, how about the resulting fraction? 6 over 7 divided by 7 can also be simplified into. If you're confused, just use a calculator, please. 6 over 7 divided by 7. What would that be? Use your calculator extensively. I keep having to ask you to use calculator. I think you need to have an awareness. Hey, your calculator is a very helpful thing.
I guess 6 over 49.
Yeah, whether you know that is correct or not, that is correct for now. Again, your calculator is helping you here. I desire all my students to, to use their calculator mightily, so to speak. Now, surprisingly, we have no y left also. That's a bit surprising. If we have no y, we have no x. We are basically supposedly done here. The only way to check, probably just check your answer key for now. Correct or not?
It's correct. Well, it's
how is it?
correct.
Okay. Now let's talk about the strategy. Or rather, before that, do you have a question?
No.
Now, here's the bad news and the good news. I'll give you the bad news first, Abigail. If this substitution method feels new to you, then that's bad news. Does it feel new?
No.
Yes or no?
No.
Your teacher have talked about this.
Yes.
All right, then let me now give you the good news. I'm not sure whether this is a good news or not. This will be the requirement for a 4-mark question in exam. They like this a lot. They like this approach or not in A math. Master
Okay.
this. I'll give you another good news. People think about it very confusingly. I think about it very simple. I see plus and minus below, I substitute. That's all.
Okay.
That's the approach that works 99.9% of the time. Okay, now we have 4 minutes left. Even though this is the first question, it already covers 2 of the approaches. There's only 2 approaches. Make the base the same or substitute. I'm sorry, there's one more. The one more is so rare. When we encounter it, I'll tell you, right? But again, your first question in the homework already covers all the strategy you need. Your whole homework is to hone that 2 approaches. Make base the same and substitute. There is no other more important strategy. Clear, yeah?
Okay.
Let's do your homework. Next question, next page. Let's see whether I'm correct or not. You only require any one of those 2 strategies. And your calculator.
Yeah. But that's it.
That's it. That's the homework. There's only 2 questions. Really.
Actually, wait.
Are you sure your homework is only these 2 questions?
Well, there's also question 3, C and E.
Yeah, go ahead, put it in.
That's it.
That's it. There's no other question for you that you want to talk about.
No.
You can already do the other homework question, is what you're saying.
Yeah, my teacher went through it during class.
Wait, I don't understand. Your teacher didn't went through question 1?
No, it's like the teacher just asked like if anyone has like any problem with the some of the questions, and then she went through the other ones.
You, Abigail, you're not the type to ask question in class. Is that true?
Yeah.
Now, Abigail, in this tuition, can you change your type or not?
Sure.
You better know. You better. As you can tell, those 2 questions turns out to review for you very important strategies. You will see those 2 strategies in exam repeatedly. Right? Repeatedly, I guarantee you. If you decide to be quiet in class, you better not be quiet regarding your problems here. If not, nothing much can help you. I cannot help you, right? Because I cannot read your mind. I can only guess. Maybe Abigail have this problem. Maybe Abigail have that problem. In this tuition, we progress according to what I feel regarding every student. I don't have a set or fixed schedule. You already know that, correct?
Okay.
You have the freedom to ask questions. That comes with a problem. If you are not good at asking questions, we do not get to address your problem. That freedom becomes a liability, a problem. It is no longer a good thing. In this tuition, every student, including you, Abigail, must make use of the freedom I gave them. Right? The other option is to follow a strict, rigid schedule so that I make sure you cover everything. Which one do you prefer? Freedom to ask or a rigid schedule to make sure everything is covered?
Freedom to ask.
Then you must use it wisely. Because the flip side of the coin is if you don't ask, the mistake is no longer mine. Do you understand?
Okay.
Better make sure you ask, right? Now, still, I'm happy for today. I'm not very happy about the speed, but I'm very happy about the concept we covered. I guess I'll see you next Thursday then.
Okay.